This episode is sponsored by Jolie Isabelle. Jolie Isabelle is a boutique soap, candle, bath bomb, lotion, and basically anything that smells amazing shop. They make all of their products with love in Lincoln, California, using all natural ingredients without the cheap filler stuff that's common in big brands.
Jolie Isabelle sent us a few products, and I love them. I've been using the soap and the lotion so much. You guys know I started using a safety razor to try to be nicer to the environment, and having a nice soap to lather up with and a lotion to moisturize after is perfect for that kind of razor. It helps my shave be so much smoother. It smells amazing. I love the lavender smell, and it really does make my skin so soft afterwards. You can just tell it's high quality, and it doesn't have that weird after lotion smell that sometimes lotion has. I'll definitely be buying more of this product when my bottle runs out.
And selfishly, one reason that we love Jolie Isabelle is because the owners are really encouraging listeners of our show. And they love science and chemistry and put that passion into the products at their shop. So check out their wonderful goods at jolieisabelle.com. That's JOLIEISABEL.com. And the link is also in our show notes.
And now on to today's show.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
Oh my gosh, I can't believe it. We are recording our 100th episode.
Yikes, that's crazy.
It's crazy and it's so exciting. And I can't believe we've gotten to talk about 100 topics in chemistry.
I know, seriously. And this is probably overdue, but we probably are due for another reminder that if you were like recently joining our podcast and listening to us, a little bit more context. Melissa is a very real chemist.
It's true.
She has her master's, she is teaching, and she is working on her PhD. She's rolling that boulder up the mountain.
It's true.
And I am definitely very much not a chemist in any way. And I studied film in college and got just the one degree and said goodbye for forever. And all my chemistry knowledge is from the chemistry class I took in high school, the chemistry class I took in college, and then now from this podcast.
From these 99 episodes.
Yes. And every time that basically that's the whole premise of this podcast. Melissa teaches me a chemistry thing. I do not already know it. And I just explain it back.
That's right. And it's been so fun. And just so you guys know where I'm at in my schooling. So yeah, I had my master's degree. That was in organic chemistry. And now I'm researching chemistry education. So I'm researching how students are learning organic chemistry. And I'm what's called a PhD candidate. So that means all I have left to do is simply write a dissertation on my research.
Nice.
So I've taken all my classes. I've passed all the big tests. Yeah, now I just have the easy step of doing research and publishing it.
Yeah. Simple. I mean, honestly.
Simple. No problem. So that's where I'm at. So I'm probably within a year of getting my PhD.
Okay. Nice.
So exciting.
Very cool.
Been in school for a very long time. Okay. So we've got two exciting things happening today.
Okay.
One, Jam already knows this, but we're going to be quizzing him. And if he gets 15 out of the 20 questions right, the next time we do an experiment together, he gets to wear the lab coat.
Oh, heck yeah. Okay.
And if you get 18 out of 20 right, I'll wear a bathrobe.
Wow. Okay. That's some serious pressure.
So that I thought was really fun. If you guys have never seen, the first time we did an experiment together, I wore my lab coat and goggles, and Jam wore a bathrobe and swim goggles.
Yeah, prescription swim goggles. Yeah.
It was delightful.
And so we're quizzing me because it's the 100th episode.
Right, and I want to see what you've actually learned.
And the tough thing about this is that even I knew we were going to do this, and we've talked about this idea a few times as a listener of a friend of ours suggested it, but I didn't study up, and I don't go re-listen to the episodes. I mean, I listen to them when I'm editing them multiple times, but I don't re-listen, so I didn't study, which is not a good way to go through school, by the way. So you definitely study.
But you did learn a little bit over time, and you had to consistently draw on your information again. So
Right.
I actually think you may have learned more than you think.
Okay. I mean, that's probably true. I do feel like it's all those specific things that you've talked about, how the difference between like learning and memorizing.
Mm-hmm.
The tough thing is that I don't think I memorize well, partly because I'm not ever tested. I'm not ever having to, you know?
That's true.
I'm just having to repeat information back to you only 15 minutes after I've learned it, you know?
I think there might be more in your brain than you think.
Okay. I hope so too.
So that's Jam's special thing for today.
Mm-hmm.
But we also want to know what you guys score on this. Without looking, don't go look up the answers. What do you have in your brain? How many of these can you get right? So if you'd share your score with us, post it on your story on Instagram and tag us, put it in a picture and tag us, just whatever on social media. If you share that with us, you listeners will be entered to win an opportunity to read our end credits.
Nice.
You will get to be on the podcast with us. You can send us a voice memo and we'll put you on Chemistry for Your Life.
You'll be famous just like we are.
Exactly right.
Yeah, we to all the couple thousand people that listen.
Yeah. We're not famous.
But yeah, we'd love that. That'll be fun to have you guys do that. So
Yeah, I think that would be really fun and I'm excited for it. Okay. Are you ready, Jam?
I think so. I'm ready.
Okay. And I did mix in. So these were questions or topics suggested by listeners,
Okay.
but I also mixed in things that I wanted to just see if you knew as a chemistry teacher.
Okay. Got it.
So I think it's going to be a mix. And some of it might be hard to remember. I did have to go back and review my notes for some of the episodes to make sure I remembered correctly.
Okay.
So don't feel too bad if you don't do great, but I think you will.
Okay, listeners, I hope that when you guys send in questions, you were trying to go easy on me a little bit and you weren't just trying to be like, ooh, I'll get him. So I'm hoping that there was some kind vibes in all of this.
I think they were excited. One person said, OMG onions, which was fun. So,
Oh, yeah. Onions. Yep.
okay. So this topic was suggested by Chelsea. She just wanted us to do anything with intermolecular forces. So I came up with a chemistry teacher question.
Okay.
What is the weakest of the intermolecular forces? If you need it, I have multiple choice responses for this one.
Let me try without it.
Okay.
Is it dispersion?
It is dispersion.
That's the geckos, what the geckos use.
Okay, so there's a follow-up question.
Okay.
Can you think of an application of intermolecular forces in everyday life?
An application of intermolecular forces in everyday life. I mean, wouldn't there be so many? I'm trying to think like all the things we've talked about. It feels like, especially for a while there, lots of our episodes talked about intermolecular forces.
We just talked about the geckos.
I mean, geckos is the best example I can think of.
Can you remember how that worked at all?
So they have all these little things on their hands and feet that are able to sort of temporarily create enough dispersion force on each of those little things that it holds their entire weight.
Yeah.
I can't remember exactly how they did that though, but
it just had so much surface area, I think.
oh, right.
They had those little hairs or something.
Yeah. They
That's
had a different
a
word
very
for
good
them.
memory. Can you think of another one? You already got the points, but we talk about it a lot, so I thought you might have one.
Okay, let me think for 1 second.
You don't have to come up with one. You already did. I just thought it'd be fun.
Okay, I can think of another one. But I feel like I would look at a list of episodes and be like, oh, duh, easily. This one or whatever. Because it's just like all these little folders in my brain.
Yeah.
And all I need to do is be reminded that the folder exists. And then I'd be like, oh, yeah.
Well, another one I thought of was honey.
Oh, like the viscosity of it. And
That's why it
stuff.
was sticky and stuff.
Yeah,
It had
yeah,
the
yeah.
intermolecular forces. And we'll talk about another application later in this quiz.
Yeah, okay.
Okay. When you cut into an onion, the molecules that make us cry aren't there yet.
Right.
Do you remember what causes those molecules to be formed?
Ooh, this is tough. Do they combine with anything in the air that's just already there?
That's the sort of the final step, but there's something that happens
Mm-hmm.
It's like a reaction.
Uh-huh.
Something facilitates it.
Okay.
I know you know it. Whenever you hear it, you'll be like, dang it.
Okay, let me think just for a second then.
Something that facilitates a reaction happening. I hope listeners at home are listening and thinking
So I
that
think
word in their brain.
the word that's coming to mind is enzyme,
Yeah.
right?
That's it.
So you're saying that is what?
That is what causes those molecules to be formed.
Right.
Those enzymes.
Okay. Got it.
Yeah, I knew you would know that.
I was like, also just trying to remember all the steps. Because I remember the way it ends is like, doesn't it end up basically being like sulfuric acid?
Yes.
And by the time it gets like in our eyes, that's it?
Yes. It connects with the oxygen, the moisture in our eye, and with sulfuric acid. That's right. Good memory. Do you remember how many enzymes it takes to make us cry when we cut into an onion?
I do not remember that.
Oh, bummer. That's okay. I didn't know if you would. That was a question from Esty. She was like, OMG, onions, how many enzymes does it make us cry? So that made me happy. It is a 2-step process.
Okay.
Because they thought it was a 1-step process, remember?
Oh, yeah.
And then they found a second enzyme that was responsible.
That's right. If
So
I was just going
2
to guess,
enzymes.
like so say it was a test and I didn't have to really explain, I would have absolutely said 2.
Nice.
Because it just would seem safer than 1. And I remember thinking it was pretty complicated.
Okay, so that's your first one wrong. But so far you've got 3 right.
Okay.
And there's a bonus on the next one. So I think you might be able to recover. So this next question is one from Tim. He wanted to know, it's a 2-part question. The second part is bonus. He wanted to know, what is a Maillard reaction?
Ooh, okay. The Maillard reaction is a polymerization of things
Can you say what that means?
which is a polymer is a small molecule made up of or a large molecule made up of small molecules. And it's like a strong ends up being this strong on a lot of things, like a layer that ends up being pretty resistant to things. And in the case of like food, it's visible to us. We see it as the brown, like crispy yumminess on things.
Yep.
And the Maillard reaction is that forming as something cooks and the like changes and reactions that start going on in our food.
Yes. That's good.
That's a pretty blanket. I don't remember like what combines with what and stuff.
That's okay. I think what you described is a good one.
Okay.
I didn't expect you to remember. It was an amino acid and a reducing sugar, I think, are the things that combine. But my answer that I was looking for was a reaction that forms a polymer that's tasty and brown.
Nice.
So you nailed it.
Whew.
So here's the bonus question on that one.
Okay.
Do you remember what conditions favor a Maillard reaction? If you can get 2 out of 3, I'll give you a bonus point.
Conditions favor a Maillard reaction.
I'm an easy grader.
Man. Okay, well, my thought would be one of them is just heat, because that favors almost every kind of reaction.
That's right. More energy a lot of times makes reactions go.
The other one would be, dang, what else is there other than heat? I guess you could say something about like the content of what you're trying to cook, probably. Does it have things in it that can form into a polymer?
Yeah, that's kind of, I would say that's, we're talking about what other conditions. You need A plus B to get C.
Yeah.
But what else?
helps? Okay.
The heat's right. High temperature is right. If you can get one other one, you'll get a bonus point. Just take a guess. I believe in you. You've got it in your brain somewhere. Can you boil stuff to get a Maillard reaction?
No.
No.
So it needs to be dry-ish?
That's right.
Okay.
Low moisture.
Interesting.
Yay, you get a bonus point.
Huh. That's a good point.
Part of why you can't boil it to get the Maillard reaction is because the temperatures can't get high enough, but also because you want low moisture.
Got it.
So boiling a hot dog is never going to get you the Maillard.
Yeah. Okay. Got it. Interesting.
And then the other one is more basic conditions rather than acidic conditions.
Okay.
Because acids can denature something, I think, is what we learned.
I almost said something about pH, but then I was like, it'd be in the thing. And then you kind of steered me away from that. So I was like, okay, maybe that's not it. But like,
that was it.
Man, I should have done that.
I knew you had it in your brain somewhere. Especially because you learn it, you repeat it back, and then you review it later when you're making edits, sometimes twice or 3 times.
Yeah.
So you know the stuff I knew better than you thought you did.
And then I cook things.
I'm so proud of you.
On a regular basis, just like you guys, and observe the Maillardness happen.
I love the Maillard reaction. It's the tastiest. Okay. This one is more of a chemistry textbook question.
Oh, dang. Okay.
Can you define boiling point?
Ooh, yes. Boiling point is when the steam pressure exceeds the atmospheric pressure.
So close.
Oh, dang it.
It's when it's equal to it.
Oh, equal. Okay.
But I'm going to give that to you.
Okay.
Because that was very impressive.
Because at least when it's equal, it has a chance to even boil. But before that, it doesn't. But okay.
Wow. How'd you have that in your brain? I'm so impressed.
Equal to. That's one of the ones that I think especially because I had such a story around that one. Why does James pot never boil? That one's really stuck with me.
Yeah. That's cool. Okay, well, that gives you a follow-up.
Okay.
Name one way you can alter the temperature at which water boils. There's 2 that we've talked about.
Okay. One would just be altitude affects boiling point because of how much atmospheric pressure there is. So
that's right.
Go way up on a mountain, go to the bottom of the ocean.
That's right.
And the other would be alter the temperature. Oh, yeah. If you add something to it that has colligative properties.
That's right. Colligative properties.
And then it would have to be higher, correct?
That's right.
Okay. Yep.
Oh my gosh. I'm so proud. I don't know if you guys listening, if this is fun for you. I hope it is, because I hope you're listening and trying to get the answers yourself and see how many you know. I am so excited every time Jam gets an answer right. Like, he's got it. He's learned so much chemistry. He knows what colligative properties are and how they play into everyday life.
Also, one thing we probably should have said is that if you want to, you could be pausing it as we go, because you might want some time to think about the questions or whatever.
Yeah, and you can share your score with us. Yeah. So, and I'm an easy grader, so if you get close, you can count it. You can give it to yourself. I probably would. I just want to make sure that you've got the big ideas right, so I don't grade nitpicky for tiny things unless like units. Those are important.
Right.
But, I usually there's a reason to my madness for why I grade why I do. Okay. This one's a tougher one.
Okay.
I had to go look this up. I hadn't thought about this one in a while.
Ooh, okay.
Do you know why mosquitoes bite some people more than others? There were 4 reasons, but if you can come up with 2, I'll give it to you.
Okay. I know one of them is body temperature.
That's correct.
Because they're looking for a nice warm source. And so that's seems to be like maybe one of the reasons if someone's a warmer person than another, they might always get bit more.
And that is especially true for pregnant women.
Oh, yeah, that's right. And the other one, I feel like there was something to do with, dang it. There were 4. Wow. This is tough.
It's tough. I had vague ideas, but I had to go look it up to make sure I had it correct.
Okay, I feel like there was something we talked about. People having different... I can't remember if we decided that mosquitoes can smell, but they can't. I remember that I was talking about ways that we can kind of throw off their senses,
Right.
And so I was thinking that maybe it had something to do with smell but not necessarily like people who are smellier, but just something that was kind of unrelated.
No, that's right. It was your skin bacteria,
Okay.
which impact the volatile compounds that the mosquitoes are attracted to.
Oh, yeah. And then we also followed up on that a little bit with deodorant later on.
With what?
Deodorant.
Yes.
But okay. So that's my answer.
Great. Good job. So the other was carbon dioxide. So it's theorized that the amount of CO2 that you exhale will impact how much mosquitoes are attracted to you.
Okay.
And so if you've worked out or something like that, and that's also probably why pregnant women are more attractive, because they exhale more CO2 and they have an increased body temperature. So the pregnant women are the key.
Yeah.
And then one study found that drinking alcohol showed an increase in mosquito landing.
Oh, interesting. I forgot that one completely.
Yeah, I forgot that one completely too. I knew the carbon dioxide, and I was thinking it was maybe the body temperature, but those are the only two I could remember.
Yeah. Dang. Interesting.
Okay. Oh, and that question was, I'm not sure I'm going to pronounce this right because it's an Instagram name, so it's hard to tell, but it's Taky. Looked like tacky or Taki D. I didn't know how to say that. But thanks for that question. And they asked with the full name of the mosquito, but I was worried about pronouncing it right. And so I altered it to make it a little easier. Okay, the next question is from Renee C. And she asks, seas are rising due to melting land ice and what other cause?
I forget the actual term, but it's that. Oh man, what is that term? Basically, the water takes up more space over time as it warms, right? So there's a little bit more space between the molecules, and that could, while there's also added volume from melting land ice, the same amount of water could still also just take up more space as temperatures are already warm anyway, and that can cause rising levels as well. But
Correct.
I do not remember the word. She
Thermal expansion.
That's right.
But that's, I think, more of a biology word. I don't think I use that term very often to talk about the way molecules move.
Oh, I see. Yeah, because I think she used it
during
the episode.
Yes.
But
thermal expansion.
Man,
that's
thermal expansion.
Correct. Next question, also from Renee C. Her two specialties. How should you treat a jellyfish sting?
Oh, nice. This is nice and recent. So there are a couple. One of them was just fresh water being applied to it. No, it wasn't. It's the opposite of that. It's actually to use.
I'm doing the shark noise, not a jellyfish noise.
How quickly Melissa paused when I said fresh water.
Yeah, I gave it away.
Okay, so seawater instead is what you're saying. The one I should have led with was that some people were saying that to try to scrape off the cells that got onto our skin by like using a credit card or something like that or whatever. That seems like maybe that would help, maybe it wouldn't. But the fresh water would actually, because of osmosis, cause those things to burst sooner.
Right. There's one other way. Can you think of it?
Oh yeah, urine. I'm just kidding. One other way.
I categorized it into two categories, and one was physically remove.
Okay.
So that was with the seawater or the scraping, although scraping's a little iffy. What about the other way? What's another kind besides physically removing?
Okay, was there something that we could apply that messed with those cells without the burrs poking us?
Yeah.
I remember you going into that explanation. I can't remember what it was.
Okay, I think we might have to count this one incorrect.
That's fair, dude.
Almost like maybe quarter credit. I'll give you like 0.25%.
If I just paused for a second and thought for a second about which kind of water, I probably would have gotten it right. I just was too gung-ho.
It's like when you answer the question before you realize there's an all of these choices.
Oh, yeah.
You circle A because you know that's right and you don't read the rest of them.
Yeah.
You did that. So you can physically remove them with seawater or the card or whatever, although the card is not officially sanctioned. That's folklore by Renee. The other option is denature.
Right.
With vinegar.
Right.
Or heat. You can heat up water.
Okay.
But heating up fresh water is risky. It's better to heat up salt water.
Okay.
And then Renee's folklore also said meat tenderizer.
Oh, yeah. That's right.
So I would have accepted one in the physically remove and one in the denature category.
Okay.
Sorry.
Dang, dude.
But you know what? You've only gotten 2 wrong.
Okay.
So that's pretty exciting. We're on question 9.
Okay.
You got 2 wrong and you earned... Oh, wait. That was question 10, actually. Question 10, you've gotten 2 wrong.
Okay.
And you have earned a bonus point. So you are at 9 out of 10.
Okay. Sweet.
Very exciting. Okay. Number 11. This one's from Brian. And I had to add a word by the recommendation of my brother. His question was, why is Teflon the worst? And I added allegedly. Why is Teflon the worst? Allegedly.
Well, chemically, I remember us just talking about some of it wasn't really necessarily Teflon on its own, although there is some there, but some of the byproducts of what happened from making it are what there seem to be a lot of alarming things about.
Yes.
And then also there does seem to be strong evidence that when it chips off and goes into our bodies, that is not good.
That's right.
Despite it not being super obvious about how bad it is or how much it would cause problems for us, it seemed like everybody agreed that it's not good to be having that go in our bodies. And like those cows died from the byproducts of whatever. So
there's one other thing. Do you remember?
I
know you know it because of cast iron.
Fumes from when when it's heated, especially if it's empty. The fumes from Teflon are not good for us.
I've heard you talk about that before. Yes. So yes, that's right. So the Teflon itself is not bad, but we don't know what accumulation in our body does. And whenever it scratches and pieces start to flake off, you don't want that accumulating in your body. The way they made Teflon and the byproducts of how it is made are sketchy, allegedly. And all those cows did die. And we watched that video and it was awful.
Yeah.
And yes, the toxic vapors will be released. I think they coated a light bulb with Teflon and put it in a chicken coop and the birds died because of the heat from the Teflon and the vapors that were released. Yeah. So Teflon's the worst, allegedly.
Yeah.
And Jam doesn't have any in his home.
We got rid of it.
I have one pan that my husband has not relinquished yet. But as soon as that thing scratches, I told him it's out and we're done.
And I've sent you guys my success with cooking eggs in my cast iron.
That's his big holdout.
Yeah, to try to prove to your husband that it can be done.
That's all we use it for is eggs.
Yeah.
So as soon as that's out, we'll be done. Okay, question 12. This is from Nicole.
Okay.
She wanted me to ask you a question related to this topic.
Okay.
So I pulled the definition from the back of my organic chemistry textbook. And I want to know if you know what this definition is.
Okay.
A large molecule made up of many repeating subunits.
Is that a polymer?
It is a polymer.
Yes.
I felt like this is kind of a gimme. And then I thought, wait a second. I'm pulling a definition from an organic textbook and Jam knows it cold. That's not a gimme. That's impressive.
Yeah. And it's like, it's really not the way that I would have otherwise defined it. Like,
right.
Even though we've all heard that word tons of times. I think the first time we did an episode about polymers, and I probably either said this or if you asked me, I would not have gotten anywhere close to that.
Yeah. So I think that's pretty impressive that you know that definition just off the top of your head. So that was from Nicole, anything about polymer chemistry. And so I thought I'd go with the definition because that would be fun. Next question from Melanie. What is the difference between a polar and a non-polar bond?
Ooh, okay. So a polar molecule has these positive and negative ends to it, kind of like a magnet or whatever.
Mm-hmm.
That then if they orient themselves together where the different sides of the magnet can bond together,
Mm-hmm.
then it's very strong, which is, I think one of the intermolecular forces you talked about was hydrogen bonding, but it's really just
Yes.
more like a force.
Yep.
And then nonpolar would, I don't know how to describe how it bonds. I don't know if I know a clear way that it just wouldn't be polar.
So I think what you're describing is intermolecular forces.
Okay.
But let's try to reframe this as a bond between two atoms.
Okay.
What makes that polar or nonpolar?
Okay. I guess it'd be the electrons having a more significant presence on one end of the bond or the other.
Right.
And then a nonpolar that'd be distributed more equally.
Boom.
There we go. Okay.
Nailed it.
Oh,
You switched over to intermolecular forces. So the first thing you described was dipole-dipole interactions for intermolecular forces. And
yeah.
hydrogen bonding is an extreme version of that,
Right.
where there's these molecules come close together and they can interact. There's like a force between them because of the pole on the one side is more negative and one side's more positive.
Yeah.
Or if they don't have that, there's the dispersion forces where when they come close together, there's a temporary.
Right.
So that's intermolecular forces. Bonding is just between two atoms.
Right.
Yeah. And so then you got it.
Okay. Yeah, that makes sense. I definitely went that other route.
Yeah. You did, but you got it there in the end. So just to review, a polar bond has unequal sharing or spread or distribution of electrons. And it does interact in dipole-dipole intermolecular forces. And a nonpolar bond equally shares its electrons between two atoms.
Right. Okay.
But they're held together by the sharing of the electrons. That's
Right.
why those atoms are held together.
Right.
Great, you got it. I'm going to give you that one.
Nice.
Once we reframed it, you knew exactly what I was talking about.
Yeah.
Okay, can you think of an everyday life application of something that has to do with polar and nonpolar bonds?
The most classic, I think, would be soap because it's got the polar part and the nonpolar part, which allows it to interact with the nonpolar grease kind of stuff that we're trying to clean,
Right.
and allows the soap and water and everything else we're doing to actually break it apart
Mm-hmm.
because it can bond with the nonpolar part of the grease.
Right. And then is water polar or nonpolar?
Water is polar.
And so it can do what with the soap?
So it can also, because of the polar part of the soap, it can
Mhm.
interact with the water and bond with it, and then basically allow there to be like, I think we talked about like almost like an adapter, because soap has the nonpolar end for the grease
Mm-hmm.
and the polar end for the water, and then it can start happening.
Yes. It can start happening. He's doing something with his hands. Yeah, they're called micelles that form around the
Oh.
soap,
Okay.
or the soap forms around the grease, I mean.
Uh-huh.
And then the water washes the micelles away. So the polar part points in and the nonpolar part points out, and that way it can interact with the water, but it surrounds that grease.
Right.
You got it though. I feel like that you just got both of those parts correct. So that's 2 points.
Nice.
So we're at question 14.
Okay.
You've missed 2
Mm-hmm.
and you got 1 bonus point.
Okay.
So you're at 13 out of 14.
Okay.
This next question is from Anthony C.
Okay.
What does hydrogenated mean?
Oh man, Anthony.
I know he got you. I forgot about that
No
episode.
mercy. Hydrogenated.
He told me he went back and listened to the beginning of all the episodes to jog his memory.
Okay. I feel like hydrogenated. Did it have to do with fats and stuff?
Oh, you just got the second question right. I said, where do we see hydrogenated somethings in everyday life?
Okay. And my thought, just based on the word and not really remembering when we talked about this, is that it has to do with hydrogen.
Mm-hmm.
And maybe I would say that there is a lot of it there.
I'm going to count that one wrong.
Oh, no.
Because here's what happens.
Okay.
There's double bonds,
Uh-huh.
and you add hydrogen to the double bonds to turn them into single bonds.
Oh, okay.
The
That sounds
hydrogen
familiar.
breaks the double bonds apart.
Uh-huh.
And so we use that. Do you remember the specific type of fat we see hydrogenated a lot?
Type of fat we see hydrogenated a lot.
Mm-hmm. There's like a specific kind you'll see it, or a specific application, like maybe in your fridge.
Butter, margarine. There we
It's
go.
margarine. So
Now that whole episode, I'm like, oh yeah, that's the episode's in, and that's like the key to that entire difference between the two. Man,
yeah, so if you have a lot of fully saturated carbon bonds, they form a consistent pattern up and down like a chevron,
right,
and they'll fit nicely in together.
right,
But if you have a double bond, that's like a little kink in the pattern. It's like a weird straight line in the middle, kind of.
right.
And so then it doesn't pack in as well. And that's why oils that have those not saturated bonds with the double bonds present
Uh-huh.
are liquid at room temperature, and something like butter is more solid at room temperature.
Right,
So to turn oil into a spread, they hydrogenate it,
right.
pours hydrogens in, but then that can have some bad side effects that have bad impacts on our body.
Right. Dang, that's a throwback for real.
Throwback. I kind of wish we could do some of those again now that we've
Yeah.
done it for longer, but
Dang,
stay true to our roots.
that's a tough one, Anthony.
Yeah, he got you. I'm going to say there's 2 questions about that, and I'm going to give you half credit. So you get 1
Okay.
because you knew about the margarine, hydrogenated oil. It was somewhere in your brain.
Yeah.
And you said it had something to do with hydrogen, but you didn't get what happened. So I'm going to only give you 50% on
I
the
had
2 of them.
completely forgotten about the bonds part of that, but yeah.
So far, out of the 16 questions I've asked, you've gotten 3 wrong
Okay.
with a bonus point.
Mm-hmm.
So you've officially, is that 14? You've officially got 14 right.
Nice.
Okay, so you're 1 question away from wearing that lab coat.
Nice.
Okay. This is from Caitlin H. She wanted anything to do with the beach because it's summer.
Okay.
So I took that to ask, how does sunscreen work?
Ooh. Okay. So sunscreen works by basically being, man, some of the molecular stuff about this is very blurry to me, but I remember it being able to be a shield against UV rays
That's right.
that typically works in 2 ways. One, it can change the energy that's coming at us in the form of UV and turn it into heat instead, dispersing it as heat.
That's right.
Or it can, I can't remember what the ratio was, what was more common, but some sunscreens also just deflect the UV rays away from us.
That's right.
That's all I remember.
So the organic ones are the ones made of organic molecules. So organic, quote unquote, in products and means something different. But the ones based in organic molecules absorb UV rays and dissipate it as heat. They absorb it. The electrons are excited. They come back down and release that energy as heat.
Right.
And the other one is a mineral sunscreen. And those are based with like metals. And they are the ones that deflect the rays somewhere else.
Got it. Okay.
Good job.
Ooh.
Correct. You officially get to wear a bathrobe or a lab coat.
Yeah.
But I don't think, you still have the chance if you get all of the rest of them right.
Okay.
Because that was question 17 for me to wear the bathrobe.
Okay.
This is another one that I pulled the definition of from the back of my organic chemistry textbook.
Okay.
The particular group of atoms in a molecule that primarily determines how the molecule reacts.
Functional group.
That's right.
Oh!
Yes. After your college chemistry class and 99 weeks of chemistry training, you know the definition of a functional group.
Boom.
I'm very proud. Good job.
I guess when you put it that way, I better know what it is. 99 weeks of chemistry lessons.
I don't know. You're not a chemist.
Yeah, that's true.
And my students will be learning about functional groups in organic chemistry this week.
Okay.
In summer 1. So,
Nice.
That really is a legitimate thing that you're learning. It's not all fun and games here. We're learning chemistry. Okay. And this last one is worth 2 points.
And this is the one that will determine if you wear a bathrobe or not.
Yeah. Part of me thinks it should be worth 3. So we'll see.
Okay.
Because there's 3 parts of the questions. Okay. Yeah. We'll give you 3 points here.
Okay.
So right now you're at 18 points. Is that correct?
Out of how many total? I've kind of lost track of that.
Wait, hang on. This is question 18. You missed 3, so that's 15. But you got a bonus point, so you're at 16.
Okay. 16 out of 18.
That's right. 16 out of 18.
Okay.
Okay. 16 out of 18. So this one's worth 3.
Okay.
Can you think of the name of a functional group, what atoms it's made up of,
Ooh.
and one of its functions?
Dang it. Wow.
We just recorded an episode where we talked about it.
Yeah. Yeah, we did. This is so hard. Okay. So I can remember a few functional groups we talked about. We talked about an alcohol group.
Okay.
We talked about an aldehyde group. We've talked about an OH group. Is that a functional group or not?
I feel like I can't comment on that at this time.
Okay. And so the second question was,
what atoms is it made up of? Which is why I couldn't comment on.
Oh, I see.
So you have to be able to associate the name of the functional group with the atoms it's made up of.
Okay, the nice thing about an OH group is that it tells me what's in it, right? Oxygen and hydrogen.
Mm-hmm. But do you know its name?
Oh, it has a different name than that. Okay. Is that an aldehyde?
No.
Dang it.
Can you think of a function? You got a name. Can you associate, could you find this functional group was in this thing that we talked about? Can you remember that?
We talked about so many. I should be able to think of one. It feels like there's so many functional groups we've talked about.
This is the pressure of me wearing a bathrobe to do an experiment. It's just so silly that you can't think straight. I really want to see that funny picture of Melissa wearing a bathrobe instead of a lab coat.
I mean, did we just talk about, was a functional group just in the anti-aging stuff?
There was a functional group we talked about.
Okay. And the question for this is, what do they do?
Yeah, can you think of the name of a functional group, what atoms it's made up of, and an application in everyday life? You can just do the topic.
Okay. Man, I think what's tough is I don't know that I can remember a specific functional group and what's made up of and its application. I don't
if you
think
can
I
get
do.
2 out of the 3, that's fine. When I tell you some, you're going to think, I knew that.
I know. I think what's hard too is that these are every lesson we have where these are in there. That's one of the hardest parts is remembering okay, what atoms in there? She just said there's a carbon chain or there's a.
Mm-hmm. Well, you don't have to get that. You can just go for the name and the function and get 2 points still. Also, I'm an organic chemist, so usually there's a carbon if you just want to get me on that.
Yeah, that's a good point. Carbons are everywhere. Okay.
We just talked about one when we recorded anti-aging.
I just can't remember which functional group it was. Was it an aldehyde?
There was an aldehyde, but it wasn't the final stage.
Right. The final stage was an acid carboxylic acid, which has carbon in it, obviously.
Mm-hmm.
And
I mean, you got it. You knew that the final step of the anti-aging was a carboxylic acid. So you got 2 points. So I'm wearing a dumb bathrobe. So you have nothing to lose.
I should have just gone with that. I was like, we did just learn that. And I remember that word. We'd even talked about how you've mentioned it a lot whenever we recorded that one. But I can't remember what else was in instead of just carbon.
That's okay. It was carbon, oxygen, 2 oxygens, and a hydrogen.
Okay.
But alcohol is an OH group.
Okay.
And I bet you can think of an application of that right now.
Hand sanitizer.
Yep.
Yeah.
So quick.
Man, dude.
Those were the two, that was the one I thought you'd go with, or the one we just did.
Yeah. Dang.
That's okay. I should have ended on a gimme.
That's hard, man.
That was a hard one. That was the biggest stretch. I would say that I thought, I don't know. I don't know about this, but I thought you could do alcohol because I think you made a joke about O. You're like, oh, OH.
Yeah.
So I think I was thinking you'd get that one.
Dang.
But okay, this is so exciting. So your final score, I'm going to give you 2 out of the 3 on that last one.
Okay.
So your final score out of 21 possible points.
Okay.
You missed 4.
Yeah. Right.
So that puts you to a 17.
Uh-huh.
But you got a bonus point.
Right.
18 points. I'm wearing a silly bathrobe.
Nice.
Good job. This makes me so happy to know that you have taken and internalized chemistry over the last 2 years.
Dude, yeah. Seriously. Kind of crazy.
Okay, listeners at home, I want to know how many points you got. It was technically 19 questions. There was a bonus point earlier on number 5. And then there were 2 bonus points on number 19.
Okay.
So 20... I guess it'd be 22 total. Yeah, 22 total possible points. So let us know how many you got right. I'm really excited to hear how y'all felt about this. And thank you so much for the questions. I loved making this episode. It was so fun.
It was very fun. I'm glad I did not totally bomb this. I was very nervous I would. So thanks for y'all's questions, guys. And thanks for some of those being fun. Also just kind of trips down memory lane of other episodes, which is pretty fun to do. So
it was really fun. So, okay, listeners, but thanks also to you guys, because we could not have made it to 100 episodes without all of y'all keeping us going, being excited, contributing to the show, giving us questions. So share your scores and be entered to win a chance to contribute to the show with your actual voice.
Yes, that'd be awesome. And as is evident from this kind of look back on our 100 episodes, Melissa and I have a lot of ideas for topics of chemistry and everyday life, but so many of our good questions and episodes have come from you. So if you have any ideas, any mysteries that you think might be chemistry, please ask us. Reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, FOR, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the cost of making it, go to ko-fi.com/Chem4Your-Life and donate the cost of a cup of coffee. But if you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That really helps us to share chemistry with even more people.
This 100th episode of Chemistry for Your Life, yay, was created by Melissa Collini and Jam Robinson. References for this episode can be found in the show notes of our old episodes that we referenced in today's episode or on our website. Jam Robinson is our producer, and we'd like to give a special thanks to V. Garza and A. Collini, who reviewed this episode.